Let's look at problem D. In problem D, notice that we have parentheses in between our two sets of exponents on the top. So we've got a 3 and a 1/4. Remember, that means we've got a power to a power. That parentheses should remind you that you're going to multiply your two powers. Well, you've got a 3/1 on your first fraction and a 1/4 on the second. How do you multiply fractions? Well, you go straight across. So 3/1 times 1/4, straight across the top and straight across the bottom will give you 3/4. So the top becomes P to the 3/4. Now I need to do the same thing on the bottom. So on the bottom, what do I have? I've got the 5/4 and the 2, and again I've got to multiply my two exponents, remembering that 2 is 2/1. So I've got a 5/4 times a 2/1 here. Going straight across the top and straight across the bottom, I get 10/4. Normally I would reduce that. I'm not going to really worry about that yet, because right now it actually helps me to not worry about that, because then I will already have a common denominator. So let's leave it as is. So on the bottom I've got P to the 10/4. So now I've got the same base of P on the top and the bottom. So that will stay the same, a P. The question is, what do I do to two exponents when I'm dividing? Well, when I'm dividing, I'm going to subtract the two exponents, which in this case is a 3/4 and a 10/4. So it'll be a 3/4 minus a 10/4. And again, I didn't reduce the 10/4, so I actually do have a common denominator, which is a kind of a good thing in my favor. So 3/4 minus 10/4 gives me negative 7/4. That's my exponent on my P, negative 7/4. Almost done. The problem with this answer is I cannot leave a negative exponent as part of my answer. So how do I get rid of the negative exponent? I'm going to move it down to the denominator. So it will become P to the positive 7/4 when I move it to the denominator. The question is, what's hidden up on top that I'm not seeing? Is that hidden 1? So my final answer is 1/P to the 7/4. In problem E, we have a completely different issue. We've got a square root times a cube root. Those are two completely different things. So the question is, can I turn them into the same type of thing? Well, I can if I turn them both into fractional exponents. So the question is, what is the square root going to turn into? Well, the square root, because there's a hidden 2, will turn into an x to the 1/2 times, well, now what does the cube root turn into? The cube root over here turns into an x to the 1/3. Well, at least the base is the same on these, so that when we multiply, the base will stay the same. It will stay as an x. The question then becomes, what do I do to the two exponents, the 1/2 and the 1/3? Well, remember, when you're multiplying, you just add exponents. So I'll add the 1/2 and 1/3, which means I need a common denominator of, again, 6. Well, that means the first fraction is going to get multiplied by a 3, giving me 3/6. And the second fraction needs to get multiplied by a 2 to get 2/6. So that when I add, I get a 5/6. So I get a final answer of x to the 5/6. Now, that's an okay answer, but we started out with roots. We should probably end with roots. So, what kind of root do we have? Well, we have a 6 on the bottom, which means I've got a 6th root of what? Well, I have a 6 as my exponent. A 5 as my exponent, so it will be an x to the 5th. Again, the 6 on the bottom was the type of root. That's a 6th root. The 5 on the top is your regular exponent. So it's a 6th root of x to the 5th. And that is our final answer if we write it in the form of roots.